Hey everyone, welcome back to Let's Code Together. Today we are diving into one of the behavioral design patterns, the template design pattern. So the template design pattern is a behavioral design pattern that defines the skeleton of an algorithm in a method, but allows certain steps to be changed or customized by subclasses. It provides a way to structure a process where the overall workflow stays the same, but specific parts of the process can be changed. In simple terms, what we can say, the template pattern lets you define the main steps of an operation in the base class, basically the template, and then lets the subclasses override or implement certain steps as needed without changing the overall flow. To understand template design pattern, let's take example of restaurant ordering system. So where they prepare the food, and to prepare any of the food item, they follow the group of same steps. We can consider this like an algorithm. For example, this restaurant has three food items: pizza, burger and noodles, right? So you can see, for example, they get an order for pizza, right? So the first step in the preparation is start preparation, and the second step is prepare ingredients, third step is cooking for that dish, and finally when the dish is ready, the last step is serve dish, right? If they get another order for burger, they are following the same group of steps for burger as well. For example, start preparation, prepare ingredients, cook dish, and when the item is cooked, ready to serve, and the last step is serve dish. And the same steps they are following for noodles, right? Now you can see for all these three items, they are following few common steps, which is like step 1 start preparation, step 3 cook dish, and finally step 4 serve dish. And one particular step is different for all these three items. For example, prepare ingredients for pizza is prepare dough, prepare sauce, and then prepare toppings. But if we take the example of burger, the prepare ingredients is slightly different, where they prepare bun and then they prepare patty and finally they prepare veggies. Similarly, for food item noodles, prepare ingredients step is different from pizza and burger, right? To replicate the same thing in software development, where we have different algorithms which follows the same number of steps, and few of the steps are common and few of the steps might be different. In that scenario, the template design pattern helps to implement such use case. In the real world, we might use the template design pattern to handle various algorithms that follow the same sequence of steps but require slight variation in specific steps. So I hope till this point, at least we are clear where we need to use the template design pattern, right? So before moving to the coding example, so let's discuss the core components of template design pattern. The first component we have is abstract class or interface. In this class, we define a template method, and the second component is template method. So we will be defining this method in the parent class, and this method defines the complete algorithm structure by calling various steps in a specific order. So in this diagram, you can see we have various steps, right? Step 1, step 2, step 3, and step 4. So which are performing a specific operation like start preparation, prepare ingredients, cook dish, and serve dish, right? So to define all these steps, we have template method in the parent class. So the template method, it defines the complete algorithm structure by calling various steps in a specific order, right? And the next component is abstract methods. So abstract methods declared in parent class but not implemented. These methods act as placeholders for steps in the algorithm that should be implemented by subclasses, right? So means if there is a step which is unique for each algorithm, right? So to replicate this scenario, so we will be declaring the abstract methods in the parent class, which will be defined inside the child classes as per the requirement. So in this diagram, you can see step 2 is different for each algorithm, right? For preparation of pizza, this step is different. For preparation of burger, this step is different. And similarly, for preparation of noodles, this step is different. So such steps we will be declaring in the form of abstract method in the parent class. So this is what we have defined here: abstract methods declared in parent class but not implemented. These methods act as placeholders for the steps in the algorithm that should be implemented by subclasses, right? And the last class is concrete subclasses. So these are the subclasses that extend the abstract class and provide concrete implementations for the abstract methods defined in the subclass. And one thing I want to add here, so in the parent abstract class, we will be defining all common methods as well. So then we need not to override or redefine the common steps in each concrete class. So those will be inherited automatically. So let's jump into the coding example where we will be using all these components and we will be trying to understand how exactly template design pattern can be implemented. So let's create the parent class. Let's call it food order. And this class is abstract class. First, I need to create template method. So which will be defining the steps of food preparation. Okay, so let's declare method public void prepare food. And this is the template method. So we will be making it final so that no concrete class can override this method. And here we will be defining the steps. Right. So we are working on our parent class and we have declared one template method, right? Another thing we need to make is abstract method or methods. So the dish specific step or steps to be implemented by subclass. So I have method abstract void prepare ingredients, right? And the child classes will be implementing this method as per whatever the algorithm or whatever the dish we are preparing. And there can be some common methods. So I am calling it common steps, which is same for each algorithm or each food preparation, right? So for example, we have method start and let's print here starting the food preparation. Okay. And the next step we have void cook. So here I am printing cooking the food order. Let's call it cooking the food. Right. Next method we have serve. So here I will be writing serving the food. So in this prepare food, so let's define the steps. The first step would be start. Second step would be prepare ingredients. Third step would be cook. And the fourth step would be serve, right? So let's quickly review this class. So first one is the template method where we have defined the various steps that each algorithm will follow, right? So in our example, we are making this software for food ordering system. So our algorithm defines the various steps to prepare and serve the food, right? So we have one abstract method. So this is the method where we will be defining the step which is unique or which is specific to particular food item. We have another methods, but these methods are the common methods which each algorithm will be following, right? So next we need to create concrete implementations for food order. So concrete implementations are like pizza order, burger order or noodles order, right? So let's create all these three classes. So pizza order extends food order, right? Let's implement the abstract method prepare ingredients. So let's print preparing dough, sauce, cheese and toppings, right? Similarly, let's create burger order extends food order, and we need to override the method prepare ingredients, and here also we are printing preparing bun, patty, vegetables and sauces for the burger, right? And we can do one thing here, let's print for the pizza, so that in printing we can see this message is for which food item. And we can create our final class noodles order, and this is also inherited from food order. Let's override the method prepare ingredients, and we can print here mm, boiling noodles, sauces and vegetables for the noodles, right? So now you can see we have three concrete classes for food order. So one is for burger, pizza and noodles, where we have defined the prepare ingredients. Those are specific to these order items, right? Let's create the client code. Let's call it restaurant. And we have main method here. So here, for example, first order is for pizza. So pizza order equals to new pizza order. And let me print here pizza order. And finally, we are calling the algorithm to prepare and serve the pizza, right? So for that we have method prepare food. So which is like template method which defines all the steps to be performed for this pizza order, right? And if I run this program, so you can see for pizza order, starting the food order, then preparing dough, sauces, cheese and toppings, cooking the food, and finally serving the food, right? Similarly, we can have one another order for burger. I am just adding one blank line here, and then we have food order, that is burger order equals to new burger order and burger order dot prepare food, right? An empty line. So let's see how the algorithm works for burger order. So here you can see starting the food order, preparing bun, patty, vegetables and sauces for the burger. Previously it was for the pizza, now it is for the burger, and then cooking the food and serving the food. So you can see we are following the same steps for each algorithm, right? Or each process, but the only one step is different for each food item. So similarly, we can have the food order for noodles, right? And noodles order dot prepare food. Run. So this is pizza order. Similarly, we have burger order, and the last one is for noodles, right? Let me print one line here is burger order and noodles order. So let me run this again. So you can see, so pizza order, same steps. Burger order, again we have same steps. And noodles order, we have same steps, right? So this way we can implement the template design pattern. Let's quickly see the class diagram. So in this diagram, you can see, so first we have a parent class, food order, where we defined some methods. Those are common for all food preparations. Then we defined one method, prepare ingredients, so which is unique for each food item. And one method we have declared, which is template method, prepare food. So where we just called each step methods. So where we are calling all the methods which are required to complete this algorithm, right? And we declared this method as final so that no child class can change its definition. And for this parent class, we have three concrete classes: pizza order, burger order, and noodles order, where we are overriding the method prepare ingredients as per the food item, right? And in our client code, we are just creating the order and we are just creating the prepare food method, which executes the algorithm in a specific order. So in simple terms, the template pattern lets us define the main steps of an operation in the base class and then let the subclasses override or implement certain steps as needed without changing the overall flow of the algorithm, right? So I hope you found this explanation of the template design pattern helpful. If you enjoyed this video, please give it a thumbs up, subscribe for more coding tutorials, and leave a comment if you have any questions. See you in the next video and let's keep coding together.